Okay, move out.
It's been said that the Army with superior weapons will win the battle. But there's more to it than that. The American fighting man is the best in the world, not only because he's the best trained, but because the vehicles, weapons, and equipment that support him are the best, and he knows it. The soldier knows he can count on that equipment when the going gets rough, and in combat, that makes a lot of difference. The United States Army understands just how much the infantryman depends on tanks, trucks, artillery, and helicopters. They must be reliable. They must be rugged enough to do the job, no matter how tough that job may be. This is the story of how the Army makes sure its fighting men are backed with the most advanced and effective hardware there is. The story of testing at Aberdeen. This is the Army's Aberdeen Proving Ground, the Test and Evaluation Command's most comprehensive facility. The site covers an area of 75,000 acres in northern Maryland and is equipped with the most modern test ranges and data gathering equipment. Here, engineers and technicians, skilled in a variety of specialties, subject vehicles and weapons to the most grueling performance tests. Aberdeen provides this service not only for the Army, but for other military services and government agencies as well. Testing programs here cover a wide range of equipment, from small arms accuracy checks to analysis of the breakup characteristics of a giant missile. But no matter what the test item, the mission of Aberdeen is the same: to make sure the soldiers of the United States Army, no matter where they may serve, are supported by the world's best vehicles, weapons, and equipment. Much of the testing is done on specially designed stress courses. This one, called the frame twister, is well named. It strains a truck's body and suspension to extremes far beyond what would be experienced in the field. All moving parts must perform free of interference. Tests on severe side slopes of up to 40% grade help determine the truck's stability, steering, and fuel system performance. A variety of brake tests are conducted on the vehicle, not only to determine reliability, but also performance under all kinds of emergency conditions. To collect accurate data on a vehicle's dynamic behavior, engineers place sensitive accelerometers at key locations. As the truck is driven over the bump courses, readings from these instruments are transmitted by radio link to a telemetry receiving station nearby. Recorded on magnetic tape here, the data is later processed through automatic reduction equipment, which translates it into highly accurate performance information. This information is absolutely essential in determining the toughness and dependability of an Army vehicle and its components. The little Army mule is known for toughness, but new models are constantly being improved. Here, vibration resistance is checked on the 6-inch sinusoidal washboard course. The bone-jangling ride continues over Belgian blocks, which give the vehicle a complex combination of high and low-frequency random shocks. Finally, an embedded rock course pits the mule against rough, natural terrain, similar to World War II's Burma Road. But probably the toughest tests at Aberdeen are reserved for tanks. Planning begins months in advance, and when the tank arrives fresh from the factory, the first step is a thorough examination. This initial inspection enables the Aberdeen engineer to know the vehicle's condition before testing starts, so he can have a set of standards to measure the results against. It's also necessary to make sure all the tank's systems are adjusted for optimum performance. In the automotive evaluation shop, experienced mechanics go over the tank's engine, making sure all its components are functioning at their best. They check manifold pressure, exhaust pressure, lubrication, and fuel flow. Related systems, such as the engine compartment's fire extinguisher, are also thoroughly checked. In combat, this system is just as vital in protecting a man's life as the tank's 2-inch armor plate. Malfunctions are quickly corrected before testing begins. Carefully reassembled, the tank is ready to roll out for its moment of truth on Aberdeen's grueling torture tracks. Here, the vehicle's engineering will be matched against the uncompromising high-performance standards of both Aberdeen engineers and the United States Army. In the Munson area alone, there are 32 courses and obstacles designed to put the tank through its paces, and then some. First, the test engineer makes sure the tank can move through loose sand without losing traction or steering control. But sand is only one type of terrain used to determine mobility. A host of other adverse natural conditions are needed to verify it. The ability of a tank to ford good-sized rivers and streams reduces its dependence on bridges and means extra speed during strategic movements. Speed that could spell the difference between victory and defeat. The tank is challenged with a variety of obstacles. One of the toughest is the trench with front and rear interference. Here, the engineer must watch closely to see if any part of the tank's chassis or armament impedes its progress. The wall climb is another important test obstacle. All combat vehicles must be able to negotiate walls of various heights. Here, the Aberdeen engineer determines the effect of angle of approach and optimum low-speed power. The engineer is also interested in learning the length of free span this tank can successfully cross. Center of gravity and weight distribution are the critical factors here. But the crucial test of track vehicle performance is the hill climb. The ability to move up a steep slope at a specified speed. This is where the Aberdeen engineer really finds out if a tank is measuring up. How well the brakes will stop and hold the vehicle. How well the engine, as well as fuel and lubrication systems, stand up under the stress. Above all, whether climbing or descending steep inclines, the tank must be under complete control. An important related factor is the amount of drawbar pull a tank can generate. This is a measure of pulling power available for emergencies, such as towing other vehicles out of trouble, operating in mud, or pushing through a dense forest. Once again, sophisticated instrumentation is used to check these critical values with the utmost accuracy. All of the many factors must be carefully considered in Aberdeen's final decision about this vehicle and whether it is good enough to support the fighting man in combat. But engineering tests under carefully controlled conditions are only the beginning. The beleaguered tank must now face Aberdeen's punishing durability courses. The Churchville test areas consist of a series of cross-country tracks with hills of every kind. There are no level spots here. These courses are especially designed to ruthlessly stress a tank's engine and powertrain to its limit. The test courses include roads of every grade, from those considered passable by normal traffic to some you could hardly call roads at all. This is the extreme dust course designed to measure the effectiveness of air filters, abrasion of parts, and degree of driver visibility. Effects of temperature extremes are not overlooked at Aberdeen. Sub-zero conditions are simulated with the use of portable cold chambers. And finally, for vehicles requiring amphibious tests, Chesapeake Bay is right at the doorstep. But even when a vehicle completes all the torturous range tests, Aberdeen engineers still aren't satisfied. Skilled technicians make an exhaustive study of all the tank's critical internal parts to determine how much wear and tear they have suffered during the tests. Together with maintenance estimates, this analysis is a critical factor in shaping Aberdeen's final decisions on whether this tank is tough enough for use in the field. Of course, the ultimate test of any piece of equipment is its performance in actual combat. But when a vehicle has been put through the testing program and approved for combat duty, there's just about nothing it can't meet on the battlefield that hasn't already been foreseen at Aberdeen. Whether grinding across country for hours at a time, clearing a path through dense jungle, or blasting away at enemy positions, the men know they've got the best there is. Delivering firepower is one of the most important purposes of a fighting vehicle, and at Aberdeen, the weapons systems which provide that firepower get special attention. On the many ranges, exhaustive tests are carried out to check accuracy, rate of fire, and effectiveness. As well as human factors, such as safety, communications, noise, and fumes. All the things which make up the complex unit that is a tank. one Aberdeen range, a radio-controlled target operates on a closed triangular rail course, moving from 2 to 45 miles an hour. It permits firing at targets moving at various angles, ranges, and speeds, enabling the most difficult firing problems to be realistically simulated. Weapons of all kinds, from the smallest to the largest, come to Aberdeen for evaluation. This is the 175mm self-propelled gun, one of the largest caliber pieces in combat use today. Upon arrival, it is given a complete inspection for soundness and dimensions. As with the tank, the engineer collects information about the weapon's condition before the testing begins, giving him a basis of comparison for later results. The gun is magnafluxed to locate any surface flaws, and bore scope to check the interior condition of the barrel. The critical inside diameter is carefully measured to the nearest thousandth of an inch, a process called star gauging. The gun must then be checked to see if there is any unusual internal stress during or after firing. To do this, strain gauges are carefully inserted into specially drilled holes. These holes must be so precisely machined that there will be no leakage, even though pressure may reach more than 50,000 pounds per square inch. Meanwhile, ammunition of a type designed especially for test purposes is carefully prepared in Aberdeen's high explosives plant. Then X-rays of the loaded shells are made to assure there are no major cavities which could cause a premature explosion in the gun barrel. The X-rays also ensure that the shells are internally consistent with those from regular production lines. X-ray and cobalt-60 techniques play an important role in many test operations at Aberdeen, helping engineers to spot defects in armor plate and to analyze the condition of ammunition after firing. The propellant charge for the test shell is carefully weighed to obtain the highest pressure within the gun's design limitations, standard procedure at Aberdeen. A rayon bag holds the charge, which is a combination of nitrocellulose and nitroglycerin. Inspection complete, the big gun is driven to the range for firing. Here, technicians make final adjustments of pressure and strain gauges used to check ballistics and assure design limits are not exceeded. After the gun is emplaced, the hydraulic loading system rams a shell into the breech. A charge is added, and the weapon is ready to fire. Not far away is an instrument trailer containing recorders and oscilloscopes used to gather the results of the firing. Normally, a smooth pressure time curve indicates a properly functioning gun. But if the curve is irregular in the rise portion, Aberdeen engineers know there is a possibility of the gun blowing up. Average speed of the shell is determined by recording the time it takes to pass between two sky screens set in front of the gun. More than one test firing is needed to provide enough data for an accurate appraisal. In the case of a firing failure, the cause is quickly determined in the nearby physical test laboratory before another attempt is made. This projectile is being measured for its degree of dynamic imbalance. Tests go on until every function has been checked. Here, the airburst performance of the shell is carefully studied on a special over-the-water firing range. By firing over water, the engineer has an unobstructed view from gun to airburst wherever it takes place. In another test, an infrared sensor is connected to a chronograph behind the gun so that the muzzle blast and airburst can be seen in the same field of view, and the accuracy of the shell's timing fuse easily measured. At the same time, test observers in a tower take transit readings of the burst, enabling the Army to compile accurate range tables for the gun. Nothing is left to chance. Since atmospheric conditions affect range of burst, these are constantly monitored by equipment carried aloft in balloons. Temperature and pressure readings are radioed back, while radar tracking of the balloon determines wind velocity. With a gun as large as this, muzzle blast is a potential source of damage and a hazard to the crew. To make sure it is kept within safe limits, several types of sensing devices are positioned around the gun, measuring intensity and duration of blast. In addition, photographs are taken near the muzzle with a high-speed shutterless camera, enabling the engineer to determine if the projectile has been damaged in firing. A framing camera is also set up to record the motion of the gun barrel with respect to the entire vehicle as the projectile leaves the muzzle and the weapon recoils. This half-mile ballistic track may also play an important part in an Aberdeen engineer's evaluation of a weapon system. Ballistic tracks are one of the most effective and time-saving techniques for weapons testing because they permit the study of high-speed action under rigidly controlled conditions. This rocket sled is designed to carry a test item into a target at blinding velocity. At the impact point, high-speed cameras are ready and rolling, recording deformation effects and other impact information. Another unique test facility serving the Aberdeen engineer is this odd-looking structure. Made of wooden target panels and aluminum foil, with light bulbs hung inside, it can be used to accurately determine the explosive capability of artillery shells, such as the 175 millimeter. A test round is placed inside, and when it detonates, fragments rip through the panels and light from the bulbs is visible. From the film record of the light, the fragment's speed can be calculated. Later, the penetrations are counted and the fragments themselves are recovered and weighed, providing a complete index to the shell's destructive capability. All of these painstaking and sophisticated tests resolve themselves into very real and important meaning when the big guns go into action, providing support for the men in the field. Now all the hard work at Aberdeen pays off, as the 175s reliably deliver shells with pinpoint accuracy on targets over 10 miles away. Aberdeen's work is not confined to ground operations alone. Wherever the defense and welfare of the United States fighting man is concerned, wherever he depends on the support of equipment and hardware, Aberdeen plays an important behind-the-scenes role. Nearly all the weapons these helicopters carry here in combat were thoroughly tested at Aberdeen before being approved as ready. The automatic high-rate machine guns, and 2.3-inch rockets in this system were given extensive ground and air tests at the proving grounds. They were flown over and over again through maneuvers that confirmed firing rate, dependability, and safety under the most realistic conditions. Conditions that left no doubt about their capabilities in combat. Effective and reliable as these weapons are, Aberdeen is constantly working on possible improvements. This is a new helicopter missile system just beginning its pre-flight checkout. In testing a sophisticated system such as this, every situation which the missile might encounter in battle must be taken into account, including vibration, shock, extreme temperatures, sand, rain, and dust. None of these must be allowed to interfere with dependable and accurate performance. Although the testing at Aberdeen is practical and real, compiled results add up to mountains of data, statistics, and figures. In themselves, they mean little. They must be analyzed and evaluated, and only the skill and judgment of the trained specialists here make that possible. Only they can decide if a piece of hardware is really ready. Because Aberdeen is the Army's senior test facility, engineers and technicians can draw on 50 years of experience with every kind of military equipment, every kind of terrain and climate. What's more, they all share the same goal: to see that the United States fighting man is backed up with the equipment he needs, the finest it is possible to build. Engineering tests are tough at Aberdeen, but these weapons and vehicles have a tough job to do. Only those that measure up to the exacting standards are fit to move out into the battlefield to support the American soldier in combat. As he moves into battle, each man knows he's backed by the best tested, best built hardware there is. That knowledge makes it possible for him to fulfill his mission with effectiveness and with confidence, no matter what it may be. That knowledge is an important part of what makes the American fighting man the best in the world today.